The short version of the second law, you can't even break even. So not only you can't get something for nothing, you can't even break even. And that's kind of discouraging. So I have a couple demos to display things. You can actually do a couple things that seem to go against that general grain. So here I've got a little basketball, and somewhere in here I've got another. Yes. So, but because of conservation of energy, when I drop this, it can't bounce higher than the height I'm dropping it from. In fact, it'll drop much less. And the same for this ball. It's bouncier. It bounces with more of its height. It returns to a higher fraction of its drop height, but it never exceeds it. But if you make a system where you have these where they can interact, then when the basketball bounces, suddenly you've got two bodies in collision, this one going down, this one going up, and the energy from the basketball can be transferred to this little ball, and it can bounce higher than what you dropped it. And in fact, it can bounce up to, well, a tiny little ball could bounce up to 9 times higher. That's the theoretical limit. So here we go. Bounced off the ceiling. So I'm going to call that a success. Okay. Let's do the, for the physics majors, I have actually a couple pages of the equations, conservation of momentum, conservation of energy, and the punchline is that when you have the two ball system, you can bounce up to 9 times the original height. So I'm not going to bore you with the details, but if you're curious, they're in the PDF mint.